Today we shall do another problem of structure analysis. Let us consider one simply supported beam of 5 meter length and it is subjected to a 35 kN concentrated load or point load at the midspan of the beam. So let us start with STAAD Pro. Go to grid, beam grid and create the grid. Select the irregular option. Give any name, select XZ, the X value should be 0 space 5. Click OK. Select this irregular beam grid. Now create the beam. Click at first node and click at the second node. Now go to properties, go to define, select the rectangle, the YD value, that is the depth of the beam. Let us put YD 0.4 and ZD 0.25. The material is concrete. Click on add, close it. Now we are going to assign these properties. Use cursor to assigning. Click on assign, select the beam, again click the assigning button. Now go to support. Create the hinge support. We have two hinge support at both end of the beam. Go to pinned and add. Select the support. You select the assign to view because we have only two nodes and both nodes will be assigned by this hinge support. So assign to view. Click on assigning, yes, OK. Now go to loading, select the load case details, click on add, select the dead load and give any title. Click on add, close it. Select the dead load, again click on add. Now we are going to apply a concentrated load or point load. So if you click on nodal load, you don't have any option to apply the point load or concentrated load at the middle of the beam. Okay. So here click the member load, and if you go at this point, there is concentrated force. You can see the value of the load will be there. You have to put the value of the load, and this D1 and D2 distance actually indicate the position of the load. So value of the load will be say 35 kilonewton. We have 35 kilonewton load. Okay, and first of all you have to put the minus because it is downward force. And now you see what is D1. D1 is actually a distance of the load from the end point, and this end point is actually the starting point of the beam. So from starting point of the beam to the point of the load will be D1. Okay, and what is D2? So D2 is the width of the beam where the load is placing. So we don't have to put any D2 value because we are going to put this point load at the middle of the beam. So we have to put only D1 value. So D1 value will be 2.5. So this is the starting point of the beam. So from this point to this point, this is 2.5. So click on add button. Now close it. Select the load. Use cursor to assign. Assign. Select the beam. Again click on assigning button. You can see our model is ready. I want to, you see, when I place the cursor on the beam, then the color is changed and the first portion is green and the middle portion is red and the end portion is blue. The green portion indicates the starting point of the beam and the blue portion indicates it is the ending point of the beam. So we are giving this 2.5 value, this point to this point. Okay, this is the starting point of the beam and this is the point of application of the load. So this distance is 2.5 that we have put it. So I am to make some shorten of this diagram. Yes, I want to scale down this diagram of the loading. So go to level setting and go to scale, check the apply immediately, and if I change this point force, if I change the point force, you can see, okay, this is better. Now click on OK. Now go to analysis part, click on define command, click the static check, click on add, close it. Now go to post analysis command, click on define command and click on support reaction, close it. I want to see the support reaction of both end. So select the support reaction, select the assign to view, assign yes. Now click on run analysis, save it. Zero error, one warning, one note. Go to output file, you see there is no error, but we have one warning, instability of joint, and two message. So don't worry, if we put the fix support at one end, this warning and message will not come. So press the control button and rotate the mouse wheel. You can regulate the zoom in and zoom out option in this position. So all those things are input file. Okay, so you can see the date of the creation of the file and unit, joint coordinate, member, so all those constant part, and member properties, width of the beam and depth of the beam. Material is concrete, loading time, value of the load, all those things. Just input file is there, and after that you can see this is the output file. The Y force is 35, total applied load, the reaction, you can see the reaction, you can see the moment also. Okay, and now close it. Now if you want to see the bending moment, shear force diagram, etc., support reaction graphically, then go to post processing mode. Okay, now if you click on FY, you can see the shear force diagram. Okay, this is the shear force diagram, and you can see at this position there is an inclined line, but we did not we did not apply any UDL. So why the inclined line is there? Because STAAD Pro make some section. Okay, so you can see there is, I think, 13 section. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 segments, that is 13 section. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have 13 section in STAAD Pro. Whatever will be the length of the beam. So if the length of the beam will be 2 meter, then also you can see the 13 section, or if the length of the beam is 10 meter or 100 meter, then also the beam have only the 13 section. The STAAD Pro make this 13 section and draw this diagram. Okay, that's why from this section to this section STAAD draw this line directly, because but it is actually wrong. The diagram will be like that. The straight line will come at up to the midpoint, and then from the midpoint it will go down, and from that point it will go in that side, toward the right side. So don't worry about this portion. Okay. So if I want to change some graphical scale, shear Y, okay, so this is the shear force diagram, and this is the bending moment diagram. Make some change. Bending Z, okay. So you can see the shear force diagram, or you can see the bending moment diagram. You can see the support reaction here. You can see the result in tabular form in this table. So in this table, the maximum shear force value you can get for different particular section. The value of the shear force is given, okay, and value of the bending moment is also given here. Now, if you want to see the maximum bending moment, click here, maximum bending moment. So at 5 meter distance, at 2.5 meter distance, the maximum bending moment will be this. And if you want to know the maximum shear force, so this is the maximum shear force, positive and negative value. Now I want to change the scale of the elastic curve. Go to scale, check the apply immediately, and this displacement portion you can change so that you can understand the displacement of the beam very well. Click on OK. Now, if you want to see the animation of the displacement of this beam, go to animation, select the section displacement. Now, make some extra frame so you can understand. Okay. And you can see the deflected shape of the beam. Now I want to change the one support of the beam from hinge to fixed. Let us see what will be the change of the analogical result. So go to utility, or you can go to support, and you can create the fixed support, or you can easily handle these things. So open the command file, press Ctrl button and rotate the wheel of the mouse. You can see 1 to paint. So you can edit these things. So node 1 will be fixed. 1, so node 1 will be fixed and node 2 will be pinned. Now save it and close it. You can see node 1 and node 2 support condition. So fixed and hinge supports are there. Now you go to analysis and go for run analysis. You can see 0 error, 0 warning and 0 note. So go to post processing mode. Okay. So now you can see the shear force diagram or bending moment diagram. The reaction you can see, this is the reaction. In part of beam result option, you can see maximum bending moment and maximum shear force value. And if you want to see the displacement, the animation, you can see section displacement. Okay, this is the displacement of the beam. You can see at this position there is no slope. Okay, at this point it is hinge, so at the beginning of the end of the beam you can see some slope is there for the maximum deflection, but for the fixed support you can see there is no slope. You can understand these things, just change the scale. Okay, you can see there is no slope at the beginning of the end, but there is some slope because this is hinge and this is fixed. Now let us try to apply another UDL. Now this is our new problem. Let us try to apply this UDL 21 kilonewton per meter, 3 meter length. So you can see this UDL is applied at the mid portion of the beam, but not the throughout the beam. Okay, so only 3 meter is the length of the UDL, but we have length of the beam is 4 meter. Now how we can apply? Select the dead load, click on add, go to member load, and this uniform force by default it is selected under the member load. Now you have to apply minus 21 kilonewton per meter. And now you have to put D1 and D2 option. What is D1 and what is D2? D1 is the distance from the starting point of the beam to the starting point of the UDL. Okay, so for our case this is the distance of D1. So starting point of the beam to the starting point of the UDL, that is D1. So D1 will be 1 meter. D1 is 1. And what is D2? D2 is the starting point of the beam to the ending point of the UDL. So this is D2. So for this case, from this point to this point is D2. So D2 will be 4 meter. So put the value 4, click on add. Yes, it will delete the result of this analysis, and I want to analyze the structure from the beginning. Yes, close. Now apply this load, use cursor to assign, yes. So we can't understand this UDL So go to view, level setting, and select the scale, apply immediately. Now change the distance first so that you can understand. Okay, it's fine. Now go to analysis and click on run analysis, save it, 0 error, 0 warning, 0 note. So there is no error. Go to post processing mode, click OK. Now if you want to see the shear force diagram, this is the shear force diagram. Just change the scale so you can understand the graphical representation. Shear Y you have to change. Yes. So you can see at this portion, this 1 meter and this 1 meter, okay, is not subjected to UDL. That's why this is the straight line portion. This 1 meter and this 1 meter is the straight line portion. Okay. If you see the side elevation or front view, you can understand. This is the front view of the beam. You can understand very well. This is the straight line portion. Is not subjected to UDL, this 1 meter and this 1 meter. So, if you want to see the bending moment diagram, this is the bending moment diagram. If you want to see the maximum shear force, click the beam result. And this is maximum shear force value. Negative value is minus 501.548 and maximum positive value is 747.144 unit, and maximum shear force is this. So this is maximum positive bending moment, this is maximum negative bending moment, and this is maximum positive shear force and this is maximum negative shear force.